In this video, you are going to learn how to calculate distances between points, otherwise known as calculating the length of a line segment, and how to calculate midpoints. So to start with, take a look at these two line segments, and I want you to make a guess for which segment you think is longer, and explain your thinking. And so to find the exact lengths of these line segments, so if we want to put numbers to this, we could put these two line segments on a coordinate plane, and then we could calculate the length of each segment. So the red segment is perfectly vertical, so we could count how many units long this segment is. So if we start here at the top, we've gone 1, 2, 3, 4, 5, 6, 7 units. But we run into a problem if we try to count how long this line segment CD is, because it's diagonal. So let's talk about a couple different ways that we could calculate the length of that line segment, and then we'll come back to this problem. So option one for calculating either, you can call it distances between points or lengths of line segments. Option one is to use what's called the distance formula. Now, I immediately look at this distance formula and I think that looks pretty complicated and that's something I probably won't remember. So we'll look at another option in just a minute, but first let's just see how this would work. So you would need to label the endpoints of the line segment over here, and then you can plug in all of the numbers here in this formula. So this point here, that's the point -3, 4. And this down here is the point 1, -2. So those are the two endpoints of the line segment. So if we labeled one endpoint with the coordinates x1 and y1, so if we call this point x1, y1, and down here, this point x2, y2, then we can see which numbers we need to plug in into this equation. So for x2, we'd plug in 1, since that's the x2 value. For x1, we'd plug in -3. Essentially, you're finding the distance between the two x coordinates, squaring that, and adding it to the distance between the two y coordinates and squaring that, and then all of that gets square rooted. Now, what I think is probably an easier option, so option 2, instead of having to use a formula, you can draw a right triangle connecting the two endpoints and use the Pythagorean theorem. So I'm going to clear what I've drawn on here so far. And so looking at those two endpoints over here on the graph, I'm going to draw a right triangle connecting them. And it does not matter if you draw the triangle down here below the line segment or up here above it. Either way, the triangle will have legs that are the same length. So using this Pythagorean theorem, if we know the lengths of the two legs, then we can solve for the length of this black line segment, since that's the hypotenuse of this right triangle, which is also C in this equation. So the lengths of the legs, we can count those since those are perfectly horizontal and vertical segments. So down here, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So in our equation down here, we've got the lengths of the legs. And remember, it does not matter which one is A and which one is B. So if you were thinking 4 squared plus 6 squared equals C squared, that would be the same thing. And then you would solve that equation for C. So 36 plus 16 is equal to C squared. And then if we add 36 and 16, that's 52. So 52 equals C squared. And to get C by itself, we would need to undo this squared. And the inverse of squared is a square root. So we would take the square root of both sides of the equation to get C by itself. And then we can type into a calculator the square root of 52. So you can do that in your phone calculator. You might have to turn your phone sideways. Or you can use the Desmos calculator and type square root of 52, and you would get about 7.21. So that is about the length of the hypotenuse, or C. So this line segment right here, it's about 7.21 units. So let's look back at these two line segments. So we counted the red one. We know that it is 7 units. Now we can use either the distance formula or the Pythagorean theorem to find the exact length of this blue line segment. Now, I've already forgotten the distance formula. It was on the last slide. So instead, I would probably use the Pythagorean theorem here. So option 2 for finding the length of this line segment. So go ahead and take a moment and calculate using the Pythagorean theorem. Calculate what the length of this line segment CD is. And so just to check our answers, this leg down here has a length of 2, and this leg has a length of 7. So 2 squared plus 7 squared, or maybe you had those switched around, is equal to C squared. So 4 plus 49 equals C squared. 4 plus 49 is 53. And then you would take the square root of both sides. So C is equal to the square root of 53, which is a perfectly acceptable answer. Or that's approximately equal to, if you type square root of 53 into a calculator, about 7.28 units. So line segment CD is 7.28 units long. So we can confirm that line segment CD is longer than line segment AD by about 1/4 of a unit. So looking at these same two line segments, now we're going to consider what is the midpoint of each segment. And midpoint does mean the point in the middle of a line segment. So just like we talked about with two different ways of calculating lengths or distances between points, we're going to have two options for how to calculate midpoints. So option 1, there is what's called a midpoint formula. So again, just like with distance formula, you would start by labeling the endpoints. So this is the point, again, -3, 4, and this was the point 1, -2. So you could label the coordinates again. So x1 and y1 and x2 and y2. And then plug in the appropriate numbers into this equation to get the coordinates of the midpoint. That's what xm and ym are. Now, this formula, I have a little bit easier of a time memorizing this than the distance formula. You're really just averaging the x coordinates, so add them together, divide by 2, and averaging the y coordinates. So this formula might be a little bit easier to remember. Or there's still another option. So option 2 involves using the slope of the line segment. So again, I'm going to erase what I wrote earlier. So if we look at what the slope of that line segment is, and slope is rise over run. So we could even draw the same right triangle that we drew earlier when we were using Pythagorean theorem. And this side down here had a length of 4, and this side here had a length of 6. So the slope is 6 over 4. Or you could even draw the triangle this way, up 6, and then to the left 4. Now, to find the point that is halfway between the two endpoints, well, we can take half of this rise and half of this run, and that should lead us to the point directly in the middle between these two endpoints. So half of 6 is 3. So instead of going down 6, if we just go down 3 units, and then instead of going over 4, we're going to go over just 2. So instead of down 6 and over 4, to find the midpoint, we'll go down 3 and over 2. And that point right there is the midpoint. And so the coordinates of that point are -1, +1. And so looking back at our line segments AB and CD, first find what the midpoint of segment AB is. So AB might be a little easier because you can just count, right? We said earlier that this is 7 units long. So half of 7 would be 3.5. So if we start here at the top, or you can start at the bottom, but we'll just count 3.5 units. So 1, 2, 3.5, and that is the midpoint. And so the coordinates of that point, so the x coordinate is 1 and the y coordinate is 5.5. So the midpoint of segment AB is 1, 5.5. Now take a moment and find the midpoint of segment CD. So for segment CD, this is where it may help to draw in the rise and the run, which again is just this right triangle, which has legs that are lengths 7 and 2. And so to find the midpoint, we're going to take half of the rise and half of the run. So half of 2 is 1, and we just said that half of 7 is 3.5. So instead of going down 7 and over 2, we'll go down 3.5 and over 1. And I'll draw in that triangle as well. So this one's down 3.5 and over 1. So our midpoint is here at 4, 5.5. So in summary, we have learned how to find the distance between 2 points, or the length of a line segment, as well as how to find midpoints. So to find distances, option 1 was to use the distance formula, but we did mention that that might be hard to memorize. Option 2 is to use the Pythagorean theorem. So if you can draw a right triangle connecting the 2 endpoints, then you can find the length of the line segment, since it will be the hypotenuse of that right triangle. So I'm going to put a star next to option 2, because that is probably going to be your easier option. Otherwise, you'd have to memorize this distance formula. And kind of same thing for midpoint. There's a midpoint formula that you could memorize. Or you can just sort of count your way to the midpoint by using the rise and the run, and finding half of the rise and half of the run to lead you to the midpoint. And so once again, I'm going to draw a star next to option 2, because that is probably going to be your easier option, so that you don't have to worry about memorizing any formulas.